welcome to phase 3, that is neural networks. So before we get started, I found this really nice article from the author Jordi Torres. That's the website torres.ai. Please do visit. And Mr. Jordi Torres is a professor at UPC Barcelona Tech, research manager at Barcelona Supercomputing Center, and a board member and analytics advisor at I Think UPC. I just love the way he writes his articles, and I'll be covering a lot of them. I'll be posting the link in the description so that you can read it yourself. What I'm going to do is just take you through the article. I've highlighted a few key points, and it will just give you a view of how a supercomputer actually aids in this process of ever evolving neural networks and deep neural networks. So this article is Supercomputing, the heart of deep learning and artificial intelligence, from the perspective of Mr. Jordi Torres, who is like, I just can't tell you, his articles are really amazing. And here we have an image of BCS CNS using DL style transfer from algorithmia.com. That's simply beautiful, isn't it? Quite powerful and beautiful. So let's get started. Now, these are the words of Mr. Jordi Torres. I'm not the owner of the article, I'm just interpreting, in my own opinion, what's his viewpoints regarding the world of AI and ML. Let's get started. Quote, surely some readers have already posted the question, why has a researcher in supercomputing such as me started to investigate deep learning and artificial intelligence? In fact, many years ago, I started to be interested in how supercomputing could contribute to improving machine learning methods. Then, in 2006, I started co-directing PhD thesis with a great friend and professor at Computer Science Department of UPC. I'm not sure if I'm pronouncing the name right. Ricard Gavala, an expert in machine learning and data mining. But it was not until September 2013, when I already had a relative solid base of knowledge about machine learning, that I started to focus my interest on deep learning. And this is the article he cites, building high-level features using large-scale unsupervised learning, written by Google researchers. And the authors explained how they trained a deep learning model in a cluster of 1,000 machines with 16,000 cores. And I believe that's quite powerful, very, very powerful. I was very happy to see how supercomputing made it possible to accelerate this type of applications. Then, thanks to Moore's law, in 2012, when these Google researchers wrote this article, we had supercomputers that allowed us to solve problems that would have been intractable a few years before due to the computing capacity. For example, the computer that I had access to in 1982, words of Mr. Jordi Torres, where I executed my first program with punch cards. It was a Fujitsu that made it possible to execute a little more than 1 million operations per second. Then, 30 years later in the year 2012, the Mare Nostrum supercomputer that we had at time at the Barcelona Supercomputer Center. So whenever I refer to BSC, that is the Barcelona Supercomputer Center, National Supercomputing Center, BSC, was only 1,000,000,000. That's quite a lot of zeros times faster than the computer on which I started. Here we have another image. That is the BCS CNS. So that's how these computers are stacked together to deliver us the computation power that they are so capable of. With the upgrade of that year, the Mare Nostrum supercomputer offered a theoretical maximum performance peak of 1.1 petaflops. That's like a lot of operations, that do of the floating type operations per second. It achieved it with 3,056 servers with a total of 48,896 cores and 1,15,000 gigabytes of total main memory housed in 36 racks. At that time, the Mare Nostrum supercomputer was considered to be one of the fastest in the world. It was placed in the 36th position in the top 500 list, which is updated every half year and ranks the 500 most powerful supercomputers in the world. Attached, you can find a photography where you can see the Mare Nostrum supercomputer racks that were housed in the Torres Girona chapel of the UPC campus in Barcelona. So that's the image. I think that's really beautiful, very neatly arranged, and would be such a nice place to work at, certainly. We come to the next heading, the first GPU in the ImageNet competition. We'll be using this word many times where we move on to image classification, but before that, a bit of story. Mr. Jordi Torres says, I discovered the existence of the ImageNet competition and the results of the team of the University of Toronto in the competition in the year 2012. The ImageNet competition, large-scale visual recognition challenge, had been held since 2010, and by that time it had become a benchmark in the computer vision community for the recognition of objects on a large scale. Now, another amazing fact over here. In the year 2012, Alex Krzyzewski, Ilya Sutskever, and Geoffrey E. Hilton used for the first time hardware accelerators called GPUs or graphical processing units, already used at that time in supercomputing center like ours in Barcelona to increase the speed of execution of applications that require the performance of many calculations. For example, at that time, the BSc already had a supercomputer called Minotauro with 128 Bull 505 nodes equipped with two Intel processors and two Tesla M2090 GPUs from NVIDIA, each one, with a peak performance of 186 teraflops. That's massively powerful, and launched in the year 2011. At that time, it was considered the most energy efficient supercomputer in Europe according to the Green 500 list. Again, I believe this is another list that lists top 500 most energy efficient supercomputers. Until 2012, the increase in computing capacity that we got each year from computer was thanks to the improvement of the CPU. However, since then, the increase in computing capacity for deep learning has not only been thanks to them, but also to the new massively parallel systems based on GPU accelerators, which are many times more efficient than traditional CPUs. Now, why are we talking about GPUs? I'll show you on my computer wherein I am using a CPU. By the time we go to image classification, you'll see the massive difference that a GPU provides as compared to a CPU. We'll have a look at this, and there are free GPU options available, which I'll share with you very soon once we get started with coding of neural networks. Let's continue. GPUs were originally developed to accelerate the 3D game that requires the repeated use of mathematical processes that include different matrix calculations. Now, in my college itself, I've been an avid gamer. I've played a lot of video games, but never ever had I imagined that these GPUs would one day act like an aiding resource to accelerate AI and ML. This like wonderful. Initially, companies like NVIDIA and AMD developed these fast and massively parallel chips for graphic cards dedicated to video games. However, it soon became clear that the use of GPUs for 3D games was also very suitable for accelerating calculations on numerical matrices. Now, this is something we'll be doing a lot when we move on to neural networks. And so, Mr. Jordi Torres continues with the headline, an exponential growth of computing capacity. I have already said that Krzyzewski's team's milestone was an important turning point in the field of deep learning, and since then there have been spectacular results, one after another, with an exponential growth of increasingly surprising results. Mr. Torres has put in a really nice graph for us. So let's analyze what's happening over here. Now these are the petaflops per day with the passage of the years. Before I tell you what's happening over here, let's read what Mr. Jordi Torres is speaking about. The graph shows the total number of calculations in petaflop per day that have been used to train neural networks that have their own name and are a reference in the deep learning community. Remember that petaflops or petaflop per day, the vertical axis of the graph that is in a logarithmic scale is equivalent to perform, this is like a big number, a huge amount of calculations for neural networks per second during a day. That's S day, or a total of approximately, again, a very huge number of operations regardless of the numerical precision. Let's have a look at the graph. So here we are. This is AlexNet, something that we were talking about just now, that started the trend of the usage of GPUs. After that, the invention of dropout. This concept also will be talking about when we move on to deep neural networks. After that, we had DQN, visualization and understanding convolution nets, VGG, sequential to sequential, GoogleNet. You can see the trend is increasing. And after that, we had ResNets, Deep Speech 2, the exception model, neural machine translation, neural architecture search, T17 Dota 1 versus 1, AlphaGo 0. Look, by the time we've reached AlphaGo 0, it's like a huge computation power, tremendously huge within a span of 6 years. I mean, we can only imagine what's going to happen in the future. That's like a lot of computation power. Accelerating deep learning with parallel systems. As per Mr. Jordi Torres, the task of training deep learning networks requires a large amount of computation, and often they also need the same type of matrix operations as the numerical calculation intensive applications, which makes them similar to traditional supercomputing applications. Therefore, deep learning applications work very well in computer systems that use accelerators such as GPU or FPGAs, which have been used in the supercomputing field for more than a decade within the walls of the supercomputing research centers. So below we have a graph. The following graph, extracted from one of our research articles, shows how increasing the number of GPUs we can accelerate the learning process. So here is the node speed up is at a scale of 4, and currently we are checking for a maximum of 4 GPUs. Below we have another image, and you can see how it changes everything. By the time we have used 32 GPUs, the speed up is quite close to something like 22 or 22.5. So GPU is just correlative, and it's directly proportional to the performance power of your systems. Next headline: will specialized hardware for deep learning be a game changer? Mr. Jordi Torres says, as of the year 2016, in addition to all the previous innovations in supercomputing, processing chips began to appear that were specially designed for deep learning algorithms. For example, in 2016, Google announced that it had built a dedicated processor called the Tensor Processing Unit, or the TPU. Since then, Google has already developed 3 versions of TPU, the last one presented in its I/O conference, where they claim that it is 8 times more powerful than the previous version. The following graph, obtained from Google Cloud, we can see a comparison of predictions per second obtained on a logarithmic scale for 3 different types of architectures mentioned above. Conventional PCs and laptops have CPUs. You might have a graphic card that would make it GPU enabled, and then we have something called the TPU, which is the Tensor Processing Unit. Specialized hardware is soon going to be a big factor in deep learning race. We will see great progress soon, I am sure, says Mr. Jordi Torres. However, even more interesting will be to see what role deep learning plays in changing hardware in the near future. The next headline, tapping the next generation of supercomputers. An example of what will be on the market in a short while is a part of current supercomputer Mare Nostrum of the Barcelona Supercomputing Center, or the BSC. Mare Nostrum is the generic name used by BSC to refer the different updates of its most emblematic and the most powerful supercomputer in Spain, and until today, 4 versions have been installed since 2004. At present, the Mare Nostrum is the most heterogeneous supercomputer in the world, with all kinds of experimental hardwares available on the market, since its purpose is to serve as an experimental platform to design future supercomputers. This is structured in that the calculation capacity of the current Mare Nostrum 4 is divided into two parts of totally differentiated hardware: a block of general purpose and a block of emerging technologies. The emerging technologies block is made up of clusters of 3 different technologies that will be incorporated and updated as they become available. These are the technologies that are currently being developed in the United States and Japan to accelerate the arrival of the new generation of pre-exascale supercomputers. One of these technologies is based on an IBM system designed especially for deep learning and artificial intelligence applications. IBM has created all the software stack necessary for it. At the time of writing this book, the hardware is available and the Power AI software package will soon be installed, which will convert this supercomputing hardware into a machine specially designed for artificial intelligence. With this software, the main frameworks of deep learning such as TensorFlow, which we will be using, and Keras, which we will be using as well, included in the TensorFlow package. These are the other packages that people are currently using to work in the field of AI and ML, called Caffe, Chaina, Torch, and Theano, which will be available to the researchers of artificial intelligence. Finally, let me summarize. In summary, it is not my intention to give you a computer architecture class, but I would like to explain and make you aware with real examples close to us that the computing capacity is exponentially evolved, and it has allowed us, as I said before, to try new ideas or to extend the old ones, since many of the advances in the deep learning era since 2012 have been guided by the experimental findings with hardware equivalent to the one that was being used in the world of supercomputer. So that's Jordi Torres for us. These are the references that he has provided. That's like lots and lots of data. Apart from that, I'd like to take you back to his website, that is torres.ai, and especially this book of his, First Contact with Deep Learning, Practical Introduction with Keras. And I'd also like to tell you one more thing. I'm not associated in any way with Mr. Jordi Torres, and nor am I endorsing his content. What I'm saying is I just like the way he writes his stuff. So that's Mr. Jordi Torres for you. I'll be covering another 4 more articles that he has written. That makes a lot of sense to me while I was in the starting stages of learning AI and ML. I hope you enjoyed today's class. Just a brief introduction about how a supercomputer researcher sees the world of AI and ML as. See you again the next time. Till then, you have a good day.